Okay, for today, you have learned several strategies that could help you solve proofs. This is not an incredibly hard one. This is actually a pretty normal proof I have up on the board here. You need to prove that the thing on the left is equal to the thing on the right. Now, the only thing I'll tell you is normally you start with the more complicated looking side and fix it. That will work, but I think it's actually easier to do it from the other side. So, if you want the ultimate challenge, try it once, and if it goes well and easy for you, try it again from the other side. It'll be a totally different proof. But do it one of the two ways. All right, I'm going to pause for a moment while you guys give this one a try. If you check your own here, let's see if you would have started properly. I suggested you start on the left side because I thought that was a little easier, but the ultimate challenge, you might have tried it from either side. You could prove this thing from either way. All right, so I'm going to multiply by 1 plus sine theta. You might think, okay, so how do you know that? How do you know to do that? Well, I know that when I multiply these kind out, I always get 1 and a minus, or whatever the number is that this times this makes, and a minus, and then this function squared. And I have it in my memory banks that 1 minus sine squared is cosine squared. So I kind of knew that that would happen if I multiplied with a conjugate. That's what you should know too, is that that's what conjugates do, is they make it into always something squared, something minus, and something squared. And you could have kind of looked ahead and saw, oh, I guess it'll end up making 1 minus sine squared if I do that. And then that's handy because that will turn into, in our next step, that will turn into cosine. But I better finish the top here. 2 times the 1 is 2. 2 times the sine theta is plus 2 sine theta. There. Now, for my next trick, I'm going to take the denominator there and make it into cosine squared. And then I'm so close. All I have to do is fix this. Somehow sine and cosecant. But, oh, I know that one. Sine is related to cosecant. You just pull out the sine and you put in what? 1 over cosecant. And then when I actually multiply that out, I get 2 plus 2 times 1 over cosecant. Just so I don't have to do a whole nother step. Isn't that the same exact thing as putting the 2 on top? If you don't get that, it's because it's 2 over 1, and so when you multiply it goes on the top. All over cosine squared. And that looks identical to what I was asked to prove, and therefore I have proven it. How many of you think you could do that level of question? All right, what strategy was it again? Conjugates. All right. So now I offered 2 options. The regular level question. How many of you chose regular level? It's not a bad choice. All right, good. And maybe some of you did regular and you did the challenge problem. But for the regular level one here, if you're following along at home, I recommend you pause me here and actually try proving this. Now, but my kids have been working on it for a while here, so I'm going to jump in. So I look at this and see, okay, would each of my strategies work? Do you think I could factor that? Not the way it is right now. Do you think I could creatively replace 1? Well, actually, maybe, because there's a 1 over here. Maybe that's an option. But if it is, I don't know how to do it. So then I'm thinking through, change everything to sines and cosines. Why should that, register with me? Yes? Yeah. On this side, there is only sines and cosines, so that should have been that's the one. Change everything to sines and cosines. So this is going to be sine over cosine plus cosine over sine. And you can't let it stop you then that they have different denominators. It is true, and it is a pain, but that's another strategy on the sheet. Get common denominators. Now, another reason you could have known we were going to do the common denominator thing was that we have 2 separate things here that need to be put into 1. To get 2 things to be put into 1 big fraction, you'll need to add them and get a common denominator. All right, so I'm going to multiply both sides by the right things to get a common denominator. This one's going to need cosine, cosine. And this one's going to need sine, sine. Because that way, sine cosine and sine cosine can be my denominator. So that is my denominator. Sine theta, cosine theta. And on the top, I can have sine squared plus cosine squared. And that sounds familiar. That seems like it should be 1 over sine theta, cosine theta. There we go. Okay, and that is what we were trying to prove. And so then to finish it off, I'd have to say equals that. 1 over sine theta, cosine theta. I'd draw an arrow down like this to show, there, I've proven it. Now, if you took the challenge one, it's a lot like this, but it looks like this. And it doesn't have that nice hint built in that, look, you should change everything to sines and cosines, because it's not in sines and cosines. So that's what makes it harder. But it's actually the other proof with just one more step. Because do you get at the end here, I can take this guy and break it into one more thing. 1 over sine theta times 1 over cosine theta. And how do I know that's okay? Because if I actually multiply it out, it equals that. And then that makes this cosecant and this secant. So I've got cosecant times secant. And that's what I was trying to prove in the high-level proof. Okay. How many of you have successfully handled every challenge I've thrown at you today? All right, it's a good sign. Do you have any questions for me about any of these strategies, anything so far? Because theoretically, we could have tested today. And I know some of you actually would have been okay. But some of you are going to probably benefit from this extra practice we're doing right now. So benefit the most by like giving me some things you want to know. Yes?
Okay, so I have it written down right here, but on the easy question, not the regular question.
The easy one version, I'll get that one up. It's right there.
So if you go to your work at the very bottom.
Okay, and my work on this one?
Yes, right there at the very bottom.
Uh-huh.
You have sine squared theta plus cosine squared theta.
Yep.
Over sine theta times cosine theta.
Yes.
Wouldn't that be sine theta times cosine theta over 1?
All right. Okay, how did I get from here to here? Well, first of all, I want to make sure if you get to this point that you don't think that you should cancel stuff like cancel, 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 cancel. Okay, that wouldn't work. One of the reasons that wouldn't work is you're canceling over an add problem. So that's not a way to handle it. What I was doing there was simply a replacement. Do you get that on the sheet, sine squared plus cosine squared is 1? So I put that there. Make sense? Okay. All right. Any other questions about anything about proven stuff? All right, so let's just go through a quick, this will help refresh your memory on, so that you're quick with these the identities on the sheet. Okay. See if you can find sine of 2 theta. Raise your hand if you got it. Okay, good. It's in the lower right-hand corner, and it is. And if you were asked to change everything in sines and cosines, is that a good time to use that? Yeah, changes things in sines and cosines. Okay. How about, what if I had tangent of theta plus pi? Can you find anything that's like that? Tangent of theta plus pi. What's it equal to, sir? All right. And you're just looking it up off the sheet, but let's think about it. Do you get tangent of theta plus pi is kind of like, here's where theta, tangent of theta would be, okay? Plus pi means it's going to go around, how far is pi? 180, okay? Do you get that this is going to go around and be down in there then, if you go around 180? And is tangent going to come out the same in there? How do I know that? All students take calc. All of them are positive here, and tangent is still positive when I move it down there, so you get the same answer. All right. Here's another one. Cosecant squared. Give me some options of things you could put in. And like you have a cosecant squared in your problem. What could you put in? Yes, sir. 1 over sine squared. That's definitely true. There's another option. Sir, back corner. Was it 1 plus that, or that plus 1? 1 with the coat is cozy, yes. So you could have put in 1 plus cotangent. Or you could have put in this. All right. Isn't there a few things that you could put in for 1? Talked about replacing 1 creatively, right? What if it's got a secant in it, but it also has a 1 in it? I don't mean 1 over secant, because that would be pretty simple. 1 over secant would be cosine. But it's got a secant and it's got a 1. There's more stuff. Which one are you drawn to then for the whole replace 1 creatively strategy? What's a fact about 1 that also has a secant in it? Yes? How about this? I'll just write the one that's on your sheet, actually. 1 with the tan is what we seek, right? And then, can I rearrange it so it's just got 1? So I subtract tan. And then 1 is that. So maybe I should put that here. All right. Let me show you the rest of this proof. Let's say it said that. Could I change everything to sines and cosines? Yeah. But this would be a better opportunity to replace a 1 creatively. Why don't you do that? Replace the 1 creatively and see what you get. This is not a proof. I'm asking you, what would you get if you did replace the 1 creatively? I'm going to pause for a second and give that one a try. Okay, so let's take a look at that strategy. Replace 1 creatively. I take the 1 out, and since I have secants and tangents, I would choose this one, which we showed how to solve, and that's 1 equals all that, right? So I put in secant squared minus tangent squared, and then which strategy comes into play? If you can factor it, you should. You can't just go cancel, cancel. Why not? Because there's addition in there. You can't cancel over addition like that. That would be comparable to saying this. Cancel, cancel. Can't do that. That doesn't work. All right. Now, if they were factored, you could. So I got to factor it. So get those cancels out of there. I take the top and I make it secant minus tangent and secant plus tangent. Then the secants can cancel, the positive ones can cancel, and I'm left with the negative ones. That's allowed, and your final answer would be secant theta minus tangent theta. And I know some of you thought you did that by just going cancel, 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 cancel. No, that won't work. That's not showing that's showing me that you know how to make a major mistake of canceling. If you factor it first and then cancel it, then it's okay. All right, so your next job is grading that quiz from yesterday. We're going to grade that in class. And then you're going to take another quiz, except this one you're going to have to do alone. All right, I'm going to pause for a moment. I'm not sure if there's more for the video, but I'll pause for now. Okay, for the sake of the video here, I'm just going to let you know what I assigned. The assignment for tonight was to look through your previous homework assignments and pick out 4 problems to re-download and do over again. Don't look at your old work. Obviously, just copying yourself isn't going to help. But pick 4 problems and build your own assignment that's at the right ability level for you. The keys are all posted now, so that obviously is okay to check your work when you're done. So let's build your own 4-problem homework assignment for tonight. That's all I got for you for today.